One of the poorest regions in India hosts a bold experiment by a group of young engineers. They utilize discarded coconut shells to construct functional roads. But this is just the beginning. Why use organic waste for infrastructure? It sounds hard to believe. Yet, the processed shells form a long-lasting surface. At first glance, it looks like simple recycling. But in reality, it changes the environment for the entire community. One can notice how the material holds firm instead of being thrown away. The secret of this process is explored with Mandarin Tech. 19 billion coconuts are harvested every single year in the fertile lands of southern India. This region has faced a tropical climate for many years, enduring heavy rains for 2 consecutive rainy seasons that are immediately followed by hot weather. This harsh weather cycle causes local roads to quickly collapse under the stress. Rainstorms relentlessly cover the base of the earth during the wet months. Why use organic fiber for heavy infrastructure? It seems counterintuitive to place biodegradable material beneath the road. But the natural resistance of coconut fiber offers stability where other materials fail. One can notice that the surface of the road is cracked and fractured due to constant expansion and contraction under the heat of the season. Facing this challenge, local engineers realized that coconut fiber, the best known for its power and natural resistance to pollution, can be an ideal material to stabilize the soil and prevent erosion. This protection produces a geo-wake shield from coconut fiber, a solution for the development of a continuous, low-water, and environmentally friendly road. This 100% natural fiber is fully grown from coconut fiber. It functions by locking the soil in its place, spreading pressure, and protecting the soil from erosion during rainy seasons. At first glance, the mat seems passive, but in reality, it allows water to flow naturally, maintaining soil structure and environmental balance. It gets more complex further on. And of course, to produce the QXA from coconut fiber, it all starts from the coconut itself. South India is the mother of the most fertile coconut city in the country. Various parts of the coconut are used for various needs. Coconut water is packed to drink. The white pulp is processed into flour or crushed into coconut oil. Even the side products are changed into food ingredients. We will discuss the use of it later, but for now, we will focus on the important part for our story: changing coconut fiber into a geotextile cloth. 10 meters, exactly the vertical distance workers must traverse to reach the canopy without any safety ropes or specialized equipment. Usually, coconuts are harvested strictly 1 year after they are initially formed. Why is this specific timing required? The fruit hangs high above, maturing slowly under the sun. This duration ensures the coconut husks are ripe enough to be taken for a meal. Workers climb the rough trunks, cutting entire bunches which then fall freely to the earth. Each individual nut can weigh more than 3 kilograms. But this is just the beginning. Gravity takes over the process instantly. In difficult fields or where trees are too high, laborers use long logs up to 10 meters in length to sever the stems from the ground. At first glance, this method seems superior due to safety, but in reality, it compromises the product. Although it keeps farmers secure, the coconut falls strongly from the height. One can notice how the heavy fruit strikes stones or open exposed roots upon landing. This violent impact often breaks the protective shell and greatly affects the quality of the nut inside. Consequently, the method is not always efficient despite the reduced risk to the worker. It does not end at this stage. The harvested batch is collected and taken to the gathering place. The material arrives at the process site on the island for skin removal. 500 to 1,000 coconuts are peeled daily by a skilled worker using a sharp wooden stick or logam. The operator manually separates the tough skin from the stem with precise movements. One can notice how the thick husk tears away from the shell. But this is just the beginning. Why does the processing speed vary so much? At first glance, The manual technique looks uniform and repetitive, but in reality, the daily output depends heavily on the size and moisture level of the specific fruit. The shredded skin makes up 35 to 45% of the total weight. This separated layer contains the precious lemongrass fiber. The material is now ready to move to the next processing phase. 2 tons of raw material pass through the processing facility every single day to extract valuable fiber from the harvest. Coconut fiber is packed into a truck and carried to the nearest processing facility, where the fibers are thrown into an open area for storage. Why is the raw fiber left under natural sunlight for 2 to 4 weeks depending on the season? To the untrained eye, this looks like a passive storage method without active machinery. However, this exposure reduces water content from about 65% to roughly 15%, softening the waste for easier separation. Heavy-duty manufacturers collect the large piles of dried coconut waste and move them to a large waste dump to start mechanical processing. One can notice how the material is thrown into a dump truck that directs it to the conveyor system. The conveyor brings the waste to the decortication unit at a stable and low speed, ensuring a flow that is sustainable for efficient separation. At first glance, the movement seems slow, but in reality, it prevents clogging while the airflow rate adjusts from about 15% to below 5% to stabilize the fiber. Therefore, the fiber combination becomes lighter, cleaner, and ready to be carried to the cooling facility. But the process is only gaining momentum. The material is moved to the maintenance area, where the machine works continuously to form a stable and consistent fiber bundle with a capacity of up to 3 tons of fiber per day. Here, the rope is loosened and sorted based on the length. Because durability is critical, the rope is selected for required pulling force so that it will not break or slip during the process of rolling the geoextile. Depending on the product needs, the rope can also be perfected to be thinner and softer according to various types of rope tools and strength requirements. After preparing, the bundle is rolled, tied, and sent to the rolling area, where its place is changed to a kind of geoextile coir, used for the strengthening of the soil, erosion, and tracks. It is visible how the fabric is rolled into a large roll, ready to be carried to road projects, location stabilization, or the area of the re-roof of the land. Average of 100 kilograms of mixed fiber can produce around 250 to 300 meters of geoextile fabric with a width of 1 meter. The cost sits between $120 and $180 per meter, depending on the thickness and density of the fabric. The product is now fully prepared for industrial application. Heavy trucks haul the geotextile quarrier to the construction area to begin the installation process. Upon arrival, the roll is lowered manually or with a specialized lifting tool, depending strictly on the size and length of the specific roll. One can notice how the crew handles the material with care to prevent any premature damage. Why is the use of a large, continuous roll so critical for this operation? Handling such massive spools requires significant effort from the team. Moving the large, continuous roll helps the installation process run smoothly without needing a lot of sewing or ironing to join separate pieces. Next, the narrow road is used to smooth the surface of the ground, removing the bumps, loose material, and uneven places along the road. At first glance, this ground preparation seems simple, but in reality, it creates a solid and even base that ensures the geoextile coir can be placed evenly without any friction or gaps. But this is just the beginning of the structural assembly. At the work site, the roll is positioned at the beginning of the road and pulled along the path by the construction crew. Workers carefully open the left geoextile roll on the ground, which is evened to ensure that it is still straight and completely touching the ground. It is visible how they align the fabric to cover the designated area precisely. Workers secure the fabric in place using a pin or pin to prevent movement during the next construction stage. The right diameter and smooth surface ensure optimal drainage, soil retention, and evenly distributed distribution. One can observe how the geoaxial care helps stabilize the soil below it by holding the soil particles in place, especially in heavy rains. The comfortable structure of the quayer spreads pressure and reduces local precipitation on weak or unstable soil. Consequently, this makes it very suitable for riverside, riverbanks, mud-soaked soil areas, and areas that are prone to erosion. The process is only gaining momentum as the layers build up. After the road is secured, the rail layer is spread over it to form the surface of the load hold. This helps to hide the axles in its place and distribute the load evenly before the ground layer is added. The roadside driver follows the place behind it to build the surface and creates a smooth and stable base, usually 10 to 15 centimeters thick, making sure it is strong enough to support the end road surface. This layer is followed by a layer of soil that creates a uniform base, as well as protects the geoexile from direct pressure. After that, a layer of solid stone is spread over the road to increase the support and repair of the drainage. One can notice how the road surface then blocks this slope, locks the stones in place, and creates a solid foundation ready for the final stage of construction. After the base is stable, the steps remain similar to building a standard asphalt road. Asphalt is spread evenly, tightened in several passes, and finished to meet the conditions of smoothness and tightness. The result is a road that looks like this, transformed into a longer road, not much crack and with a longer life, even in harsh weather conditions. 1,000 liters of liquid accumulate in the stainless steel cooling tanks within mere minutes of the production line starting. Why must the temperature drop to exactly 4 degrees Celsius so quickly after extraction? The tropical heat trapped inside the nut promotes rapid bacterial growth that spoils the taste instantly. This immediate, controlled cooling is the only way to arrest enzymatic changes and lock in the delicate nutritional profile. The process begins when the raw coconut enters an automated system where a precision bore descends. The drill cuts a small, clean hole through the hard outer shell to access the sterile reservoir inside without contaminating it. One can notice the clear stream of coconut water rushing from the nut into the collection pipes. But this is just the beginning. Filtration is the next mandatory phase for the extracted liquid. Because physical contaminants, residual oil, and microscopic dirt particles must be removed, the fluid passes through a series of fine industrial meshes. The water is strained for a while to ensure every trace of bacteria is eliminated before it is cooled once again. This multi-step purification guarantees the liquid remains fresh and safe for consumption. The cold, sterile water travels to the modern storage and packaging line. Here, the liquid is injected into aseptic cartons composed of multiple layers of paper, polyethylene, and aluminum to block out light and air. The entire production line operates with ruthless efficiency, boasting a capacity of up to 6,000 cartons per hour. At first glance, filling a carton seems like a simple mechanical task, but in reality, the sterile air pressure in the chamber prevents any airborne contaminants from entering the package. It gets more complex further on. While the water is secured, the coconut meat takes a different path. The tender white meat is collected manually or mechanically after the hard shell is cracked and discarded. The solid flesh is cut into uniform small pieces and transported to an automatic washing system. High-pressure water jets batter the coconut chunks to strip away stubborn skin, sand, and dirt. Some advanced factories even utilize warm water or a light disinfectant solution to achieve clinical levels of cleanliness before processing. It is visible how the gray dust washes away, leaving behind glistening white coconut meat. The washed chunks are fed into the hopper of a high-speed industrial grinder. Blades spinning at thousands of revolutions per minute turn the solid meat into a smooth, consistent mixture. This mash is then conveyed to the pressing station, where it undergoes either mechanical or cold compression. The equipment gradually forces the mash through filters, separating liquids from solids. The process is only gaining momentum. A hydraulic press applies immense force to separate the precious oil from the fibrous dry matter. This cold press technique is critical for preserving the natural aroma and ensuring high moisture levels are not lost to heat. The extracted oil is strained carefully to remove fine sediments before being transferred to the storage area. One can notice the golden oil slowly separating from the white pulp under the weight of the press. Therefore, bottling is the final step for the refined oil. An automatic filling system measures the exact volume and releases the oil into stoppers, glass jars, or plastic bottles. The environment is kept strictly sterile to maintain quality and consistency. Finally, the bottles are sealed and labeled, ready for long-term storage. And this is not the limit. Another section of the facility grinds the meat finely to produce rich coconut milk. The creamy liquid is transferred to a fully automatic packaging line that cleans, prepares, and seals the containers in seconds. A single factory unit manages to process up to 2,000 cups of coconut milk per hour. The equipment gradually moves the white cups along the conveyor belt in a synchronized rhythm. The sealed cups are then subjected to high-pressure processing. This advanced technology subjects the product to a staggering pressure of up to 600 megapascals. This force destroys bacteria and pathogens completely without the need for thermal treatment. Consequently, the product preserves its natural nutrition much longer than traditional pasteurization methods would allow. After the pressure treatment, the system packs the cups into transport cartons, typically arranging about 24 cans in each box. Machines seal the cartons and apply labels with barcodes for inventory tracking. This ensures the products can leave the factory and reach supermarkets and consumer tables around the world safely. Transition to the next level. The coconut meat also undergoes a transformation into colorful traditional sweets. Slicing machines cut the white flesh into thin, uniform strips with a thickness of about 2 to 3 millimeters. These delicate slices are immediately rinsed with warm water. This step reduces the natural oil content and softens the strong raw aroma. The rinsed slices are drained and moved to large cooking vats where they are mixed with sugar. The mixture simmers over medium heat for 45 to 60 minutes. This slow cooking time is essential so that the sugar can absorb completely without breaking down the coconut's cellular structure. It is visible how the strips turn translucent as they soak up the sweet, boiling syrup. It does not end at this stage. To extend storage time, the sweetened coconut is dried until it reaches a specific moisture content of 60 to 70%. This precise drying extends the storage time while maintaining the characteristic softness and aroma. Steam slowly settles as the dried petals cool down on the metal racks. The final product is moved to the packaging area. Workers or machines distribute the sweets evenly into Ziploc bags or plastic pouches within a clean, dry environment. Each bag is sealed with heat to prevent moisture ingress. The packages are labeled with the production date and expiration date, ensuring the sweet treat is ready for its journey. Two specific dates, production and export, are stamped to ensure food security. Why is this tracking critical? At first glance, it seems simple, but in reality, it validates the entire processing chain. And this is not the limit. One can notice how fibers strengthen roads, turning raw husks into durable infrastructure. From construction materials to practical health and beauty items, the coconut proves there is no wasted part. The ordinary material becomes extraordinary